Yo, what's going? Guys, I haven't been live in ages. I don't even remember how to use YouTube anymore. Testing, innit? Can you guys see me? When was the last time I went live? I think it was... Yo, Swaro, what are you telling me? Yo, Kaz, I think the last time I went live was what? The 28th or 27th of June. It's been so long. Sienna, what's up? I've already covered this in maths. Should I stay? Yeah, why not? You haven't seen every question in the world for this topic, so it's still worth it, I would say. It's only an hour. Sorry, June 18th. Do I remember what? Yo, Clang, what's up? Do I remember the what? Sorry. Is that to do with Primate? I can't remember. Was that when we did statistics? Yo, Ishak, what you saying? Kebab, what you saying, man? Hey, yo, Primate, where is Primate? I don't have a clue. Hey, yo, I can't believe there's over 90 of you here. Hey, yo, if you're here, there's over 90 of you. Say Wagwan, innit? Shristi, what's up? Welcome back. Rin, are we going to do exam questions? Yeah, of course. So all this, guys, summer school is an introduction to year 13. So I'm not going to be doing... I'm not going to be revising year 12 stuff. So what I'm going to be doing is introducing you guys to year 13 concepts. So you're going to get a good feel as to how I conduct my full course. So a lot of you who are in the chat right now are actually on my full course already. So I'm warming you guys up into it, and you'll get like a good understanding as to how I do things, innit? And some of you guys are probably going to be doing the science and what is it? Yeah, the science A-level ones as well. You'll see how we do things. Lungang, trust me. I haven't said that in time. It's been like nearly a month and a half. Ayo, what's up, man? Season Apocalypse, we saying? Hadi, yo. We've done some of this further maths as well. Yes, it's good for revision as well. Yo, Zam, we saying? Lavianch, what's up? So, let's see if I remember how to write on these. So just a quick introduction, if you guys don't know who I am already. Rayham, what you saying? I'm good, man. Darker, woke up 10 minutes ago. That's crazy. Alvin, what's up? I'm good. So yeah, if you don't know who I am already, guys, I'm the head of maths at My Ed Space. Fully qualified maths teacher with over 8 years of teaching experience. 9 years if you include my training year. So I guess Unc status is confirmed, isn't it? I can't call myself a Ute anymore. First class honours degree from UCL. Did maths, straight maths, and also for my A levels, 2 A stars, 2 A's with my Aorish or violin. The A star in maths, guys, I did it in year 12. So I'd already got my A star in maths at your age. So I'm trying to teach you guys to be the same, innit? So today, as you've seen from the beginning, we're doing radians and circular measure. As you guys are already familiar with, degrees, innit? Degrees. But there's a new way of measuring angles, and it's known as radians. And if you were in my course last year, you've seen that the layout to the PowerPoints have changed. It actually looks really clean. I'm actually digging this new style. What do you guys think? If you were in my streams last year. So what are radians? So if you're coming into year 13, you've all been used to solving trig in degrees. Now we're going to learn radians, innit? Yeah. So since degrees have a unit of measurement, it has a unit of measurement. A radian is a new way of measuring an angle. Now a degree, guys, is known as a planar angle. Yeah, it's known as a planar angle that is defined that a full rotation is 360 degrees. Yeah, you guys are very used to that. You've learned that since the beginning of time when you were youths in year 7. Now, the question is who decided that a full rotation is 360 degrees? Yeah, why is that the case? Have you guys ever thought about that? Who decided that this is 1 centimeter? If you pick up an object, who decided 1 kilo is 1 kilo? Why is it that that mass is 1 kilo? Have you ever thought? It's a bit of a philosophical question, yeah? So, why is it that a full rotation is 360 degrees? Now, it's just something that was fixed a long time ago. And the most likely, God did, maybe, the most likely explanation as to why is that in ancient times, with the use of sundials and through observations of the constellations, making a full rotation every day, yeah, so the rotation of the Earth, it was easy for old mathematicians to equate 365 days to approximately 360 degrees in a full rotation. Because technically, a full rotation around the sun is this. 360 degrees does the job well enough. And as Sienna said as well, 360 degrees has many, many factors. So there's a couple of things here. Yeah, so in terms of old mathematicians, a full rotation around the sun, 365 days. They've essentially rounded it down to 360 degrees because it has more factors. Yeah, and it's just an easier number to work with. Better than 370, yeah? So there's no concrete answer as to why why mathematicians agreed 360 degrees. But I've given you two kind of reasons as to why they've come to that conclusion that 360 degrees is a good number to use, yeah? Justina, are you in full screen? Are you on full screen? Are you in the highest quality of YouTube as well? Make sure you set the quality to 720p or 1080p. I think it should be on 1080p. Now, here come radians, guys. Oh, actually, sorry, I didn't say this bit. Now, it's not useful for us when performing important calculations involving calculus. So calculus, guys, what do we mean by calculus? See if you need to warm up your brains. You guys been chilling for too long. What do you mean by calculus? What two topics are involved in calculus? Shristi, integration, good, and its counter opposite. JMB, it does. That's what calculus does measure. Differentiation. Felicity, good. Alicia, good. Differentiation and integration. So, guys, in year 13, like 60% of it is calculus. And everything we do is going to be in radians. And the reason for that is radians is what we call a unitless measurement. This is a unitless measurement. Unitless meaning, for example, when we say centimeters, centimeters is a unit. Yeah. When we say kilograms, kilograms is a unit, 1 kilogram. Yeah. Radians does not have a unit. It's actually a ratio. Yeah. So a radian is a ratio. How does it work? If you're new here, whenever you see a yellow box that looks like this, it means it's an important piece of information that you need to remember. Yes, most likely going to be a definition. Now, a radian measures the ratio between the arc length of a circle and its radius. And if I was to tell you that again in simple English, what it does, a radian tells you how many times bigger the arc length is compared. I'm going to rub out that arrow in a second. Compared to the radius. Yeah. That's all a radian tells you, is in a circle, how many times bigger is the arc length compared to the radius. That is it. Yeah. So how many times bigger is the arc length, you know, that the proportion of the circumference, how much bigger is that arc length compared to the radius? So what do you think 1 radian means then? About the radius and the arc length. Yes. I will do. And you, in terms of definitions, you don't need to, but you'll get used to it anyway. Samir, good. 1 to 1. Yeah. Arminal, that's the conversion. We'll deal with that in a second. But nice, guys. It just means they're the same. 1 radian. So I'll tell you in terms of what I wrote above. 1 radian means that the arc length is 1 times bigger than the radius. Well, if you're 1 times bigger than the radius, it just means they're the same length. Yeah? So 1 radian, let's write this down. It's easier to write it down in simple English, and then, you know, going forward it makes it easier to understand. So 1 radian means that the arc length... Hey, yo, Ibrahim. This guy. Shouldn't you be enjoying your summer holiday? This guy. So the arc length is 1 times bigger than the radius. Yeah. So if you look at my diagram, guys, it means that this is the radius. This length here would also be r. That's all it means. That's all it means. Can you guys see at the center here, I have 1 radian. Can you see there's that C? That C is not a unit, because you know in degrees we have this, right? That is a unit of degree. That C is not a unit. It's just indicating to observers that it's a radian. Yeah, so C is not a unit. It's just to indicate to people who are like maybe coming in out of nowhere to look at the question that we're dealing with radians. Yeah, and a lot of you are saying 180 over pi. We're going to do the conversions in a second. Yeah. Okay. So if I changed it to, if I change this to 2c, yeah, so 2 radians, what would the arc length be? So remember, a radian, yeah, that number at the center just tells you how many times bigger that arc length is compared to the radius. Alex, good. Samir, it would be a 2 to 1. Srishti, essentially, don't forget your R. Kai, nice. Rayhan, sorry, does this topic come up in the A-level exam a lot? As in, this is one topic of the whole trigonometry course. As in, these questions, I'll show you some questions later, but they can be 5 to 7 marks in terms of what I'm going to show you after. Nice, guys. So a lot of you are saying 2. When you guys are saying 2, you're saying it's 2 times bigger than the radius, so we'd say 2r. Yeah? So it's 2 times bigger than the radius, so we're going to say 2r. 2 is the angle at the center, yeah? But all that number is saying is that when you multiply that by the radius, you get that arc length, yeah? Okay, so that's the definition of a radian. And as some of you are deriving the general formula for the arc length, we'll do that in a second. Now we need to know the conversion, yeah, between degrees and radians. What's up, Ghost Girl back? So, what is the angle in a semi and full circle in radians then? Okay, now, in general, let's do it generally. We call this R. Now, in a semicircle, guys, what would this length be? This arc length. So first tell me, what would that arc length be? So and I see some of you have seen this before. I want you to derive, because what happens in school is that teachers just tell you the answer. They tell you what it is. I don't like that. I want you to understand where things come from. Why is it what it is? Good, it's pi. Yeah? So this length here, guys, is pi but r. Good, exactly, pi r. Because we know that in a full circle, if we look here, this would be 2 pi r, right? So a semicircle, the arc length would just be pi r. Well, if the radian tells you how many times bigger the arc length is compared to this, what would the angle at the center be? So this number that we put here is what you need to multiply the radius by to get this. So what number would we put in the middle? QWERTY, good. Ethan, good. Exactly. It's just pi. Yeah? Because we're saying you need to multiply the radius by pi. Yeah, you need to multiply these two together to get this. Yeah? So, in radians, pi is the equivalent, pi in radians, if we put a C there, is the equivalent of 180 degrees. Yeah? So pi, that angle, when you multiply by this, you get this. Yeah? So, nice kitten. Or kaitan. See the... Well, it's probably kaitan, not kitten. Okay? So that's where the conversion is coming from. So, if we look at a full circle, guys, what would the angle at the center be? First was right, kaitan. So what would it be? Exactly, MD. 2 pi. Tim, good. Kaz, Samir. Anirudh, nice. 2 pi moi. Yeah? So when you take the angle at the center and you multiply by the radius, you get the arc length. Yeah? Now you could have done that conversion just from pi being 180. Kind of follows on, right? So 2 pi radians is 360 degrees. Yeah? But at a base level, guys, we like to use the fact that pi is 180 degrees. Yeah? So very important when doing conversions, pi radians is 180 degrees. So maybe box that yourself. And we're going to use that to derive a conversion. Yeah? Hence, what can we say is the conversion between radians and degrees? So as you guys know from, what is it, like year 5, I'll teach this, not this kind of maths, but in terms of conversions, if you want to convert between radians and degrees, you need to know what 1 radian is. So if pi radians is 180 degrees, what would 1 radian be? So using this, guys, if pi radians is 180 degrees, what would 1 radian be? Michael, nice. So there you go, guys. 180. So you're just dividing by pi on both sides, right? So you're over here. Over here, you're just dividing by pi, isn't it? Like that. So 180 degrees divided by pi. Nice. Let's just make a note. And yes, JMB, that is approximately 57.3 degrees. So if you guys want to remember, 1 radian is about 60 degrees. Yeah, if you're going to round it, you're just saying 1 radian is about 60 degrees. So this is from radians to degrees. I like to think of it as to go from radians to degrees, you want to get rid of pi by dividing by pi, and then you making it larger by multiplying by 180. Using that same idea, how would you guys go from degrees to radians? So now you're talking about what 1 degree is. Nice, Annie. So using that same idea, nice one, Mike. We are going to divide both sides by 180, right? So as long as you know the base conversion, the rest of it is pretty simple, right? So we're going to do pi. So I like to think of it as we're introducing pi now, yeah, by multiplying by pi. Then we make the number smaller by dividing by 180, yeah? I don't know why I wrote degrees there. Doesn't really matter. Technically, this is all in radians, yeah? Okay, it's that simple, yeah? So that's how I remember it, because I don't always do this conversion. I say, look, to go from radians to degrees, I want to get rid of pi. So I'm dividing by pi. Then I multiply by 180. To go from degrees to radians, I want to introduce pi by multiplying by pi. Then you always do the opposite with the 180. So you're dividing by 180. Yeah? So what would 60 degrees be then in radians? So, whoops. So in radians, remember, you are introducing pi and then getting rid of the 180 by dividing. Nice, pi over 3. And as you guys start writing these down over and over and over again, 60 degrees is probably the most common. 60 degrees, 30 degrees, 45 degrees, 90 degrees. We're going to be writing these down so much that you're just going to tell me straight away the more year 13 maths that we do. So let's just write down our working though. 60 degrees. So remember, I want to introduce pi. Yeah, so I want to introduce pi by multiplying by pi. And then I want to make it small. I'm going to divide by 180. Yeah, so that's coming from, which one? This one. Wait, where am I? Yeah, degrees to radians here. It's this one that we're doing. And that takes you to pi over 3 radians. Now, you don't have to put the c if you don't want to. Yeah. And you feel free to use a calculator if you want. What would 270 degrees be? Felicity's got 3 pi over 2. 1.5 works as well. Grr. You're doing part C, bro. Okay, good. So, here, guys, we're timesing by pi. We're introducing pi. Priscilla, good. Dividing by 180. So, this is going to be 3 over 2 pi. Or 3 pi over 2. However you want to write that. Very common. Yeah, very common angle. And then finally, this one should be an easy one. Due to simplification. What would this one become? Aisha, does it... So, keep it like how I'm doing it. So, don't decimalize unless they want you to. Yeah, so obviously this one, it doesn't actually simplify at all. When you times that by 180 over... times by pi over 180, it just stays like that, right? Now, in the exam, most likely they would ask you to decimalize that for some reason. But in general, that's it. It's just something that doesn't simplify. Yeah? All right, cool. Let's go the other way. So remember, guys, when we want to go from radians to degrees, we want to get rid of the pi through division, and then we're going to multiply. So pi over 4 is what in degrees? And this is one of those which we would remember. Yeah. Yeah, good. 45. Rohan, nice. Cheeky 45. Is on good. So, you guys all right? So, remember, I always focus on the pi first. So, we need to get rid of pi by dividing by pi. And then we're going to introduce 180 by timesing by 180. And it is a 45-degree angle. Very common. Yeah, if you do further maths and you've done Argand diagrams and stuff like that, this should be an angle you've seen hundreds of times, right? All right, 7 pi over 10. What's that one saying? Doing the same thing. 126. Whatever that is, bruv. Yes, bruv. Looks like 126 degrees. Nice one, Mike. Now here, guys, 1 decimal place. What would this be? 0.65 radians. I'm going to put a C on there. 37.2, is it? 117? Oh, wait, sorry. Did you times it by pi? Oh, wait, hold on. Did you times it by 180? Actually, I'm not sure. Wait, hold on. We're all getting different answers. ¿Qué pasa? Hey, yo, check out my calculator, though. Seems a bit big. Is that because I'm sitting up? Guys, how are we all getting different answers, Mike? 0.65 times 180 over pi. Do you guys have this calculator? This is the best calculator in the world. I hate that they changed it, man. Okay, there we go. Even if your calculator was in radians, it won't matter. You see, look at the top here, guys. I'm in degrees. If I shift the menu and change it to radians, it doesn't make a difference. Yeah. The reason for that is because we are dealing with multiplication division. Yeah. Mandem, how are we getting 117? I don't think they divided by pi. So if I times this by pi, 117. Yeah. So those of you who got 117, you just didn't divide by pi. That's all. Yeah. Don't forget, Mike. Don't forget, Mike. 37.2. Nice one. Alrighty then. Now, of course, yes, so guys, you only really need to be in radians when doing trig calculations, which we're going to do next lesson. Yeah, we're going to do next lesson. Sophia, I mean, you could, as in it's not wrong, but you have your calculator, right? You have your calculator. Sophie, 117, you haven't divided by pi. That's all. Guys, look at my calculator screen. Look at my calculator screen. So those of you get 117, you just didn't divide by pi. All right, so these are the common angles you guys need to know. We did this one. We did this one. We did that one. Actually, I've shown you all of these already. Yeah, it's just 90 degrees is pi over 2. Makes very much sense. Bad English, but if you just divide that by 2, there you get that. And this, no, not that one. This, if If you divide that by 2. Pi over 3 divided by 2 is pi over 6. So these are very common angles. You guys will get used to it. Yeah. Sketch the sine, cosine, and tangent graphs in radians. Would you guys feel comfortable drawing these graphs? Do you guys remember them? When you've done it throughout your careers now. Only between 0 and 2 pi. Rohan does. So this is between 0 and 360 degrees. Easy peasy, squeeze the lemon in that. So let's do the sine graph. Sine graph starts at 0, 0. One full wave. Nice. Lol, my teacher was tell us that pi was half term. Yeah, that's what I told you guys. That's usually what teachers do, but I don't like that. I like showing you guys where things come from. Yeah. Okay, so let's test you guys. What would this angle be in radians? Radians. Pi. Darker. Yeah, good. Good, Felicity. Pi. Yeah, because that's going to be half of a full turn. This is 2 pi. This here we know is 90 degrees, which is pi over 2. And this here is 270 degrees, which we showed earlier was 3 pi over 2. Yeah, nice. All right, cosine. Cosine. So cosine starts at 1 and does 1 full wave. Beautiful, mate. Beautiful. Similar vibes. Here we end at 2 pi. Here's in the middle at pi. And here you have your 90 degrees, which is pi over 2. And 3 pi over 2. I think it's a lot like learning a language. Well, maths is a language. At first, when you do these, you're going to be thinking in degrees and converting. Eventually, you're going to just be thinking in radians. Yeah, but that takes some practice. It's the exact same as learning a language. With learning a language, you always think in English and then you convert it to the new language. Then eventually, the more and more you practice, you just think in the new language, right? I'm trying to learn Italian and right now I'm just thinking in English. It's not easy. It's not easy learning a new language. English is a really easy language to learn compared to the other ones, man. Are there any questions in year 13 that would ask us to use degrees? Yes, Tim, for sure. Mechanics is going to be all in degrees. Well, until we do calculus. Bro, I'm already learning a language at A level. Yo, darker, that's crazy. Learning languages at A level is probably one of the hardest A levels you can do. Man, like Liam, how's your cat, bro? Yes, most of it will be in radians though. Arminor, I'm not sure. Chapter 6 is different depending on what exam board you're doing. So what topic is that? So guys, with the tan graph, what exists? That's very important. Cat's doing good. That's good, man. That's good. My cat's doing good as well. The asymptotes is on at pi over 2, yes. So this at 90 degrees, guys, for the tan graph, yeah, has an asymptote. Asymptotic behavior. And then we got a full wave. It looks a bit like the x cube graph. And then one more. Okay. So label it. So we've got 0. That will be pi. So 2 pi, half of that here, pi. Now there's the asymptotes at pi over 2, 90 degrees. And 3 pi over 2, 270 degrees. And that's it. Now at year 13, we're going to look at transformations of graphs in radians, which is... whether you're doing in degrees or radians is tricky. But then we're also going to learn at transformations of the recip graph. So sec, cosec, and cot. Yo, Venki. Hope you're having a good summer, dude. Nice one, White. Now let's look at arc lengths. So let's look at the actual formal kind of, well, the typical exam questions they like to ask. They're very similar to GCSE, to be fair. It's just all done in radians. I think it was your year group where you had those 2 overlapping circles, I think. It's basically to do with this stuff. So, from GCSE, how would you find the arc length of a circle in degrees? So, how would you do that? If you guys remember from your GCSE, how would you find the arc length of a circle in degrees? So, sorry, that's in radians. How did you guys do it in degrees? Aisha, pi over 360 times pi r squared. You're very close. That was for the area. 2 pi r. Yes. Let's see. Recip graphs are my arch nemesis. I can only draw the cot graph. Hey, the cosec and sec graphs are alright. It's just like I just think of it as like a roller coaster. They just keep jumping from top to bottom. So, the arc length, let's just call it we'll just call it arc length. So at GCSE, you would do theta over 360. You'd say what fraction is theta relative to 360 times the circumference of a circle, which is 2 pi r. Okay. Now we can easily convert that into radians. And all you have to do is convert 360 degrees into radians. So guys, 360 degrees, what is that in radians? What is 360 degrees in radians? 2 pi. 2 pi. So, let's call the arc length L is theta over 2 pi times 2 pi r. What do you guys notice happens here? What do you call it? Oh my god! They do cancel. Oh my days, bro. That's crazy. The pi's cancel and the 2's cancel. L is theta r. And this is where it comes from. So if you've seen it before, I'm showing you where things come from. But also, I've also introduced this to you already. A radian tells you how many times bigger the arc length is compared to the radius. That's it. We did that at the beginning, and a few of you were saying that already, but this is how you derive it. You don't need to derive it, you know, in the exam, because it's just a definition. But if you ever forget it, then you can just go back to your GCSE definition and derive it yourself. Yeah. So a radian tells you how many times bigger the arc length is relative to the radius. Nice one, mate. Just some other definitions you need to be aware of is what we mean by major and minor arc lengths and that. So, sector. A sector just means if you take a piece of cake and you cut a normal slice. The smaller slice is known as the minor sector. And the bigger piece is known as the major sector. So in the exam or any kind of question, just make sure you're reading. What are they interested in? Are they interested in the minor or the major sector? Usually what they do is they just draw the part of the sector that they're interested in. But you never know. Yeah, you never know. Myth King, are these sessions on YouTube? Yes, they will stay on YouTube. Yeah, they will stay. So and it works the same way in terms of the major and minor arc. So minor sector, minor arc. Major sector, major arc. Yeah? Sigma sector, alpha sector. Huh? What are you on about? Grr, do they give that formula? No. But don't worry, you'll remember it. Guys, don't worry about memory. Trust me. Especially in my main course, like we use this stuff so much that you don't consciously think about remembering things. You will remember them naturally. Lungang. yeah. Okay, so areas of sectors and segments. So from GCSE, how would you find the arc length? I swear I changed that. Man like Dom, you know. How would you find the area of a sector? Can you guys change that? Area of a sector. You don't even need of in degrees. How would it change? Yeah, this is the pi r squared version. Yeah, so we're going to say the area of sector is theta over 360 degrees times pi r squared. Now converting to... Oh, Ethan, it's changed on the worksheet. Oh, okay, fine. My slides are bugging out then. So 360 degrees we know. So you guys should be able to tell me what the result is. So we got the area of sector in radians, 2 pi times pi r squared. In this case, only the pi's cancel, right? Ooh, wait, all the pi's. Boom. Theta over 2. Now, the way we write this is the area. So we like to write a half r squared theta. I personally don't write theta r squared. In general, we like to write r squared theta. Okay. If any of you are doing further maths, you're going to do polar coordinates. And in polar coordinates, you're going to find areas of polars. And you're going to be introduced to a formula that uses this. Areas in polar looks like this. I don't know if any of you guys do further maths. It looks like this. So keep an eye out. It just comes from this. You're taking the sum of areas for things defined in polar form, which is pretty cool. I digress. Find the area of a shaded segment. So how would you guys find area of a shaded segment? What's the strategy here? What's the general strategy? NJ, area of sector minus triangle. Swallow, good. So segment area is sector area minus triangle area. Now, in this case, what formula would we be using for the triangle area? Brev. Tim, you're just missing a coefficient there. Igor. Nice. Nice, guys. So half AB sine C. And yeah, your area of sector, we have to use radians. That's all. Yeah. So, guys, for the triangle, our A's and B's are both R, isn't it? Yeah. So it's going to become area of the sector, which we just said was a half r squared theta. So everything we're doing right now is in radians. Yeah. Minus a half AB. So your AB R sine of the angle in size of the angle theta. Yeah, all in radians. And Felicity, you are correct. So the R times R is R squared. Now it's true that this is fine, but you should also notice that both of these terms have common factors. Half R squared. And we like to factorize that out. It makes it a little bit simpler for us, especially in some tougher calculations. Yeah. So the segment area is a half r squared. Then you just look at what's left. Theta minus sine theta. And that's it. Now, do you need to remember this? No. You can just derive it yourself. Yeah. Guys, with something like this, you will have written it down a few times, but it's one of those things where in the exam you can just figure it out in your head. You're just doing half r squared theta minus half r squared sine theta. You factorize it. It's not hard to derive it. Yeah, this is why I show you guys everything. Does the triangle area formula still work if the angle? Yes, Izan, it does. It's just you have to make sure that the angle you use is in radians. That's all. Yeah. So all the formulas that you guys know in degrees still work in radians. You just have to make sure the angle is in radians. So cosine rule, a squared is b squared plus c squared minus 2bc cos a. That works still. You just have to make sure the angle you use is in radians. That's all. Yeah. Yo, Farhan, what you telling me? Dark, and in these lessons will we cover stuff like U sub IBP? What's IBP? Are you talking about integration, Darker? Then no. We're not going to do year 13 integration because we don't have enough information. We don't have enough. The general population of year 13s do not have the required knowledge for integration yet. Rayhan, because long hair is just too much effort, dude. Way too much effort. I don't know how you people who with long hair do it, man. I did it for 5 years and I was done with it. Okay, so guys, to find the area of this shaded segment, what would you guys do? Other than deriving, will we need the degree version of the formulas? No, Ian. You won't need the degrees for stuff like this. Proper flashbacks, Farhan. I see you're missing the grind. You guys been chilling for too long. Well, the results day is in 10 days. Exciting times. Rayhan, centimeters to meters. You're on the right line in terms of something. So Tim is saying sub into the formula for segment. So, and Carl is, what's up, Carl? So from the last slide, guys, the segment area was a half r squared theta minus sine theta. Yeah? So tell me, is this fine? Are you guys happy with this? Kai, I see you, dude. Yo, Ted, what are you telling me? Hey, yo, my old year 13s can't help it, man. Nice. So, on my main course, I always get the year 13s with this. Always get them. So, guys, it's not correct. Unk's still grinding, obviously. I took July off, though, to chill. So, here, guys, make a note. Yeah, just make a note. Maybe put a box around it. If you have something, a different color, it's good to just make a note here. So, no. And just make sure we need to convert to radians. Okay. So 150 degrees, guys. What is that in radians? Yeah, so you'd been away. Yeah, it was all right, Ted. It was all right. Although I was ready to come back to the grind. I was ready to come back. Lewis, 5 pi over 6. Said the same. Tim got the same. I'll remind you guys how we do it. I minus pi over 3. Ayo, dark ass. The longest. I mean, I guess you can do it that way. Do we got the same? I8. Okay, cool. So Priscilla as well. So the way I remember it, guys, to go into radians, we need to introduce pi. We're going to multiply by pi. And we do the opposite. We divide by 180 degrees. Yeah? Okay. 5 pi over 6. No, Sophie, because you're going to be doing sine of that angle. Yeah, and even this 150 here. Yeah, this 150 here. That also needs to be in radians. But because you're doing sine of the angle, that whole ratio gets messed up unless you're in radians. Yeah? So you can't convert at the end, guys. You have to do it before you compute the sine. Yeah? If that sine 150 wasn't there, then you'd be all right with it. But because there's sine of the angle, you have to convert it. Yeah? Yeah, 5 pi over 6. Now we can do it properly. Yeah? So we have... No, NJ, like I said, you have to convert it before you do sine of the angle. Otherwise, the whole thing gets messed up. So now it's a half r squared. Then we got 5 pi over 6 minus sine of 5 pi over 6. Let's do it together and I'll show you if you then convert it to degrees, it's not the same. Yeah? So you have a half of 6 squared, 5 pi over 6 minus sine, sine of 5 pi over 6. That's a half. Okay, do you guys get the same as me? About 38.1. Nice. This would be centimeters squared. I'm wondering the same, Kebab. Double check. Make sure you use the brackets in the appropriate place. Are you in degrees? Maybe you're in degrees. Let me check. There you go. Kebab, you're in degrees. So just shift. Let's get that into radians. Just press equals. It will change. Yeah. Alex, you're in degrees. So we should all get this. Make sure at the top, guys, it says R. Rayhan, if you leave in degrees, you get the 12691. And yeah, if you guys times that by pi over 180, it's not going to give you the same number. We'll check it. How do I change into radians on call? Huh? Sophia, what's on call? Sinathrai, you should always be in radians. Yeah. All angles will be done in radians. Calc, I meant. Sophia, so can you see it says setup in yellow? So you need to press shift. Yeah, you need to press shift. Then the menu button to go to your setup. Then number 2 for me says angle unit. Press number 2 and then change it from there. Yeah. So make sure in radians. Yeah. If you guys had kept it at 150, say you guys were in degrees and you kept it at 150, would it still give you the same number? Let me show you it doesn't. Okay, so you get this. Yeah, you get a really nice number if you guys do it in degrees and you use 150. Then if we do the conversion times by pi over 180, so if you do that conversion, you see that does not give you the same answer. So you can't just convert it at the end. So you have to be in radians at the beginning. Yeah. Ethan, graphical calculator is the same thing. You're just shifting and menuing your menu buttons here, right? So you're just doing shift and then menu, and then you do the same thing. Yes, Rayhan. Always. Radians. Always. Okay. PQ is an arc of a circle of radius 10 centimeters, center O. Given that the perimeter of the sector OPQ is 32, find the angle in radians subtended by PQ at O. This looks very messy. What would you guys recommend we do here? So much words. Definitely a strategy I would employ here, which I would always be good. Kai, Darker, good. Manuela, nice. We should be drawing a diagram. The arc of a circle of radius 10 has center O. So we're looking at a sector. Yeah. Whenever there's loads of words, guys, draw a diagram and the whole thing becomes a lot simpler. Okay. Neil does art and that. So it's saying PQ is an arc. PQ is an arc of a circle, radius 10, center O. Given that this whole perimeter is 32, find the angle at the center. So if they've given us this whole perimeter, what could we state straight away? So if the perimeter is 32, what can we immediately say? Good. 12 is the arc length. Yeah, 12 is the arc length because this is 10. Good. This will then be 12. Okay. Now we want the angle at the center. Let's call it theta. Can you guys write me down something which connects theta and the other numbers? So what connects theta and the other numbers in the question? And yes, Felicity, that is true. JMB, L equals 12. Okay, L equals 12. Yes, that is true. But Kaitan, that is correct. That's what I want to use. L, the arc length, is r theta. Yeah, nice, guys. So L, the arc length, is the radius times theta. Yeah. The arc length is how many times bigger. Wait. A radian tells you how many times bigger the arc length is relative to the radius. So here we're saying the arc length is 12. The radius is 10 theta. So theta is 1.2. Bro's lost. I'm finding my brain again. Remember, all it's doing is saying the angle at the center is 1.2 because 12 is 1.2 times bigger than 10. And then finally, we're going to do the area. So remind me, guys, what's the area of a sector? I mean, if you can decimalize it, in radians in general, it's easier if you can decimalize it to like 1 dp, but otherwise you can just keep as a fraction. Yeah, especially when we have things in terms of pi. Nearly Sophie, just missing one thing there. Squared, nice. So half r squared feta cheese. So the area is a half. The radius is 10 squared times feta. What does that give? 160? Not 160, I mean just 60. And that would be if we were doing the segment there. Andy agrees with me. 60 centimeters squared. Nice. There we go, mate. There we go. Nice one, guys. Nice one, dive. Next one. In the diagram below, OAB is a sector of a circle radius 5. The chord AB is 6 centimeters long. Find the area of the shaded segment. What do we find first? Yo, Big M. Welcome back, dude. I'm excited for next week, I can't lie. Gonna get bare messages. Felicity, find theta first. Good. So we don't actually need the arc length here, guys. We want the area of a segment, and we know the area is dependent on theta. Now the question is, how are we going to find theta? How are we going to find theta? Good, Declang. We are going to be using the cosine rule. Yeah, cosine rule to find theta, because what type of triangle are we looking at? Ruwei, we will be using that eventually when doing the area of the segment. But in this case, we need to find theta first. It's isosceles. Isosceles, yeah? It would be equilateral if they were all 6. If that 5 and 6 were the same, then it would be. But only these two are the same. Yeah, so we're going to use the cosine rule. Cosine rule rearranged is cos A is, whoops. Even I've forgotten the cosine rule. B squared plus C squared minus A squared over 2BC. Okay. And in our case, we have cos theta. Now your B's and C's are 5. 5 squared. 5 squared. B, C, A. Minus 6 squared over 2BC. Then we're going to inverse cos all that. Let's type this in first. 25 minus 36 over 2 times 25. So we get that. Now it's inverse cos that. So you're going to do inverse cos answer. What are you guys saying about my number here? How's it looking? Michael seeing something. Valid. It's in degrees. Don't want degrees, guys. Don't want degrees. Arco as well, 1.29. So here, guys, you're going to go. The annoying thing is if I do inverse cos now, because I've used the answer button, it's not going to work out. So I'm going to first convert it to radians, but you just need to change this answer back to 7 over 25 and get the actual answer. Yeah. Just keep that in the calculator screen. Yeah. Then clock. You'll get used to it. Don't worry. Guys, you will get used to it. And now we can use our area formula for the segment. Yeah. Dory Sienna, you got this. It's just you're just practicing a new skill right now. So remember, it's a half r squared. Theta minus sine theta. Remember, you can derive it very quickly yourself. So it's the area of a sector minus the area of a triangle. And you're just factorizing. Yeah? Yes, Mohammed? So the radius in this case is 5 squared. Then we have 1.287 dot 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 minus sine of 1.287. Tim, they can get way more difficult. Way more difficult. But it's all geometry style stuff. Now here, guys, just use the answer button. So I'm also showing you how you compute things in the calculator much easier. So over half, 25, answer minus sine answer. Make sure you double close that bracket, otherwise you'll get a syntax error. Syntax error means that you're missing a bracket somewhere. Noor got 4.1. Nicholas as well. Soham as well. Boom. Should we say, yeah, 4.3 SF, 4.09 is, I think, good enough. 4.09 meters squared. Yes, mate. Yes, mate. Hey, and are you in degrees, my friend? Finn, for year 13 obs, we've done year 1 content fully, but we need to look back in that book, or can we solely concentrate on the year 2 book only? Finn, I would focus on year 13. You'll learn year 12 again intrinsically through doing year 13, yeah? So don't stress too much. Okay. Guys, I won't do this in the full year 13 course. But because it's summer school, I thought we could do like a quick Kahoot. It's just 3 questions, isn't it? Okay. Just a quick one. It's 3 questions. Kahoot things. I actually don't know what the questions are, so I'm going to join in. You guys ready to play some Kahoot? I'm being nice with you guys. Wait, can you guys hear? Alright. I'm going to put it in the chat, guys. You don't need to scan anything. Check the chat. Just click that link. What do you mean not that song? This song is sick. Alright. This is me giving you guys false expectations though, because in year 13 when we start we won't be able to do Kahoot because we never have any time. Alright, I'm in. You can also change your person. Alright, I always have my standard. Alright. Alright, come on. I'll give you guys like 30 seconds. Whose maths does Neil? Also, yeah, if some of you guys don't have TikTok and you can't follow Maths Does Neil, on Instagram, there's Maths Does Neil. Wait, if you can't follow Neil Does Maths on TikTok, I upload the same videos to Instagram at Maths Does Neil. So depends where you are, really. Let's see. Okay, 5, 4, 3, 2, 1. So remember, guys, it's only 3 questions. 3 questions. Yes, Lavianch. These are only warm-up sessions. Alright, double points. Convert 120 into radians. Because, Lavianch, this was only a small snippet of the full lesson, so... Have you ever seen Maths Does Neil and Neil Does Maths in the same room? I'm dead. Okay, most of us got it. So guys, if you remember, 60 degrees is pi over 3. All you're doing is doubling it. Yeah? So 2 pi over 3. Rah, Lewis, yeah? You think you're quick? Yeah? You think you're quicker than me? So ham and cheese. Okay, next one. Let's go. True or false? Double points. The area of a sector in radians is given by this. I think I was first there. Surely, mate. Kaitan, need to catch up, mate. Come on, we should have all got our answers in by now. Alright, it's false. There's no half there. Where's the half? Hey, yo, Liam, you're bugging out. Oh. Okay. Will anyone be able to beat me? Come on, guys. It's time to wake up. It's time to wake up. Jack the Lad, up 24 places. Last question. Let's go. Double points. Find the arc length of this sector. Find the arc length. Oh! Oh! I think I'm going to win this. Let's see who can beat Maths Does Neil. Hey, yo, only 40 answers. Hey, yo, nah, you guys bugged out. There was over 90 people playing. Only 90 people playing. Josh, I don't subscribe to anyone on my work account. I only use YouTube to stream, to be fair. Alright, so what are we saying here? So, arc length is just radius times the angle at the center. But the problem is that it's not in radians. That needs to be converted, which is pi over 4. Pi over 4 times 12 is 3 pi. Okay, let's see. Sienna, you didn't need a calculator here. Alright, did I win? KC, nice. Lewis had a downfall. Anirud, I think I won. Come on. Guys. You guys need to get on my level, man. Next time. Next time. We're all warming up our brains. Keep in mind, I don't make these cahoots as well. No, JMB, I don't make these cahoots. Try hard. I am a try hard for real. But it was man like Dom makes these. You guys let me win, of course, of course. So guys, remember, wait, our next lesson is what? On Wednesday at 11. So we're going to be solving trig and radians, so don't miss it. Also guys, remember there's homework for all of these. So make sure you do that just to get familiarized with the topic again. If you have any questions, in the description, it says tech issues. So you can use that number to message if you want to get on the platform so you can do the homework as well. Yeah? It's only 3 questions for homework. Yeah? Alright guys, enjoy the rest of your day. Well done. I'll see you guys later. Peace out, homies. Well done for warming up your brains. Catch you guys later. Sweet. Nice.